Very good morning. So, we are learning advanced machine learning. Today's topic of interest is ensemble algorithms, bagging, random forest, and the textbook being referred for this is Master Machine Learning Algorithms by Jason Browley. So, all the contents of today's discussion are derived from that textbook only. This is the textbook I was referring to. So, we're speaking about random forest. Okay, it's an ensemble machine learning algorithm. Random forest is also called as bootstrap aggregation or bagging is its short form. What is a bootstrap? So we are estimating a quantity from a data sample. So we will come to know whether the quantity is a descriptive statistic such as a mean or a standard deviation. Let us say we have x and there are 100 values of x and we want an estimate of the mean of the sample. We can calculate the mean directly from this sample using this formula. What is mean? Mean is basically an average. So this is a small sample and this sample has error. So what we can do is we can improve the estimate of the mean. What we have done here, we had a data sample, we had calculated its mean and we are sure that there is an error. So to improve this estimate, we are using Bootstrap. What happens in Bootstrap? Sorry, you'll be creating random subsamples, many random subsamples using replacement. For each subsample, calculate the mean, then calculate the average. So let us say we have taken 3 resamples with these mean values. So we'll be taking the average, which is coming to be this. So the same bootstrap process can be used to estimate standard deviation and learn coefficients. Bootstrap aggregation is also called as bagging for short. It's an ensemble method. What is an ensemble method? An ensemble method, you will be combining predictions from multiple algorithms and make more accurate predictions. So bootstrap aggregation is used to reduce the variance for such algorithms who are having high variance. Examples of high variance algorithms are decision trees, CART. Decision trees are very sensitive to data on which they are trained. If the trained data is changed, the resulting decision tree can be quite different and the predictions can be quite different. So what happens is bagging will be applied to a high variance machine algorithm such as decision tree. So let us say we have a data set of 1000 instances and we are using CART. So what happens here is in bagging is you'll be creating many random subsamples with replacement, training CART model on each sample. Given a new data set, you'll be calculating the average prediction for each model. Bagging naturally will be used for classification and regression problems. Random forests, which we have seen, are an improvement over bagged decision trees. What is the problem with decision trees like cart? They are greedy. They choose which variable to split using a greedy algorithm, which will be minimizing the error. So naturally, bagging will also have the similar concept, and there will be a high correlation in the predictions. So we'll be combining predictions from multiple models in ensembles. This will be good if the predictions from the sub-models are unrelated, weakly correlated. So what random forest will be doing is will be making changes algorithm so that the predictions from all the subtrees have less correlation. Usually in cart what happens is you will be selecting an optimal split point, while the random forest algorithm will be doing what is it will be selecting a random sample of features, limited that too. Let us say the number of features at split point M are there. There is a good analogy here. The good default is M is equal to square root of phi. This is for classification. For regression, the good default is M is equal to P by 3. So what exactly M is? M is the random selected features that can be searched at a split point. And what P is? P is the number of input variables. Let us say we have a data set of 25 input variables for classification. So M will be equal to square root of 25. M will be equal to 5. Now the estimated performance, what happens in a bootstrap is there will be some left out bootstrap samples. These samples are called as out of bag samples or OOB. The performance of each models on its left out sample when it is average can provide an estimated accuracy of the bagged models. This estimated performance is often called as a OOB estimate. This performance measure is a reliable estimate of the test error and correlation. It correlates well with the cross validation estimates of the error. Importance of variables. When we construct bagged decision trees, we can calculate the error function drops for a variable at each split point. In regression problems, this can be sum square error, and in classification this can be Gini score. These drop in error can be averaged across all decision trees and output to provide an estimate of the importance of each input variable. The greater the drop when the variable was chosen, the greater the importance of the variables. These outputs can help identify subsets of input variables that may be most or least relevant to the problem and suggest at possible feature selection experiments you could perform when some features are removed from the data set. This was about the concept of random forest, bootstrap and bagging. Let us directly refer the textbook and see the example tutorial for the same. This is the textbook I was referring to from the prescribed syllabus by Jason Broley. We are directly referring the contents from here. So we are speaking about bagging as an ensemble technique. This is the data set. We have x1 and x2 and we have the output variable y, and we can see there are two classes 0 and 1. So your data set has around 10 records, and these records are split into two parts, phi of category 0 or class 0 and phi of class 1. This is the output. And this is the graph for the same. So 0 are marked as blue colored one, 1 is marked as red colored ones. Now what we are doing is, this is our data set. Now we are selecting split point for the data sets like this, because we want to make subsamples, right? So for model 1, the split point is x1 less than or equal to 5.38. So let us see, less than or equal to 5.38 means this will come, 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 and these three will not come. This again is less than or equal to 5.38. So first 5 samples, then 6, 7, 8, and 9th sample. So first 5 samples and 9th sample. So for the first split, and each such a split will be called as a stump actually. This was for the split point x1 less than or equal to 5.38, is it not? Now here we know that first 5, when I split, on the left side the first 5 will go and the 9th one will go, and on the right side 6, 7, 8 and 10th will go. So left will be class 0 and right will be class 1. So we can see that this is our prediction, right? First 5 zeros, 6, 7, 8, 1, the 9th one is 0 and the 10th one is 1. So this is my error. Error is happening at the 9th instance. So the accuracy is coming to be 90%. Now for the decision stump model 2, we are taking x1 less than or equal to 4.09. 4.09 means, let us check here. So this will come, this will come, this will come, even this will come. Rest all will be on the right side. The above first 4 will be on the left. So fifth one also is 0 actually, but the prediction goes like this here. This is for model 2. The first 4 are on the left side, rest are on the right side after the split. So this is our prediction. At the 5th instance the prediction went wrong. So this error is 1 instance going wrong, so 90% accuracy. Now for the model 3 we are taking x2 less than or equal to 0.925. So let us go back here again. x2 0.925, so 0.925, this one. So this one and this one, rest are all above. So for the model 3, 1, 2, 3, 4, 5, 6th instance and the 10th instance, sorry, and the 9th instance are going to the left, remaining all are going to the right. So if you see here, the 2nd instance and the 5th instance are predicted correctly. It means the previous 2 instances of 2 models are predicted correctly. So here it went wrong because at the 3 instances the prediction has gone wrong. Error this 1, 2, 3. 10th instance, 8th instance and 7th instance. How the final prediction will be? Now we have 3 predictions for the 3 subsamples, 3 stubs. Model 1, Model 2, Model 3. This is Model 3, 70%, Model 2, 90% and Model 1, 90%. So what we'll be doing is we'll be taking the mode of this. So if you take the mode of this, you'll be getting the prediction to be 100%. So this was a small example for random forest bagging. Thank you.